Hello friends, myself Salil Gadgil. I am a mathematics teacher. In this video, I am going to explain why angle around a point adds up to 360 degree, as this forms the starting point for our geometry. Let us learn more about it. So in this segment, we are going to discuss about how is the angle around a point 360 degrees. This is more of a story rather than any valid proof. So a few thousand years ago, there was a civilization named Babylonian, and they had a counting based system of 60, which would mean like we have 10 digits, right? 0 till 9. All our numbers are based on digits 0 to 9. So they had 60 different digits or maybe 60 different symbols at that time, and the number 60 was because 60 has maximum number of factors. So if they wanted to count say 20 sheep, then it would be 1/3 of 60. If they wanted to count say 24 cows, it would be 2/5 of 60, and so on. So 60 has maximum number of factors, and that probably was the reason why 60 was chosen. Now what they did was, and that's why if you notice 1 minute is 60 seconds and 1 hour is probably 60 minutes. So that is the significance of that number 60. So now I am going to explain this concept using a figure over here. What I have done is, I have drawn a circle of random radius. I have taken it about 12 inches on my board, and with the same measurement I have drawn 6 arcs on the circle. So you can start with any particular point on the circle. So I have located the center O. So this is the center of my circle. Then I have located a point which is in horizontal alignment with O, and from A, with the same measurement as the radius of circle, I have drawn 6 particular arcs. So A, B, C, D, E and F. Now what I am going to do is, I am going to join. You can even try this on a sheet of paper. You can draw a circle, you can mark these particular points, and you can also measure things along with me. So I am going to join OF along as well as OE, and I am also going to join EF. So if you have drawn this, you notice that you will get a triangle. If you measure the angles of this triangle, these angles turn out to be 60 degrees. So if you take your rounder, if you take your protractor and you measure these angles, you will find that each of these measurement marks actually is equivalent to 60 degrees on your protractor. So what the Babylonians noticed was, if they had an equilateral triangle cut out, you can also check all the sides. If you measure these sides OF, OE and FE, you will notice that all these measurements are actually equal. So you can measure it with a scale, and you will notice that these measurements are actually equal to the radius of your circle. So since Babylonians had this base of 60, they said that each angle in this particular triangle equals 60 degrees. So the first thing that they observed was all the angles were equal, and since they had a counting base of 60, they said that let's mark each of these angles as 60 degrees. Okay, so this is why angle in an equilateral triangle conventionally is 60 degrees. The next thing that Babylonians noticed was, if they actually start cutting out such equilateral triangles, so if you take a big piece of wood and you cut out an equilateral triangle out of that wood, and you keep cutting 6 such equilateral triangles, they noticed that they were actually able to make a hexagon out of it. So you can actually try this on the sheet of paper that you have. If you join all these triangles, so all the points that you initially marked, if you join them with the center of the circle, you will notice that you start getting these equilateral triangles. So Babylonians noticed that if they took 3 such triangles, they were actually able to cover half of the hexagon. So again, each of the angle over here is equivalent to 60 degrees. So this part is also equivalent to 60 degrees. This part is also equivalent to 60 degrees. And then they later on found that if you actually have 3 more equilateral triangles like these, you can actually cover up the whole circle. So let me mark a 60 degree here, a 60 degree here, as well as a 60 degree here. You have 3 equilateral triangles so far, and they found that if you extend this idea to 6 equilateral triangles, you actually start getting a complete hexagon. So if I were to join these, I would get a hexagon. So Babylonians found that each angle of an equilateral triangle, they labeled it as 60 degrees because their base of counting was 60. They also found that 6 such equilateral triangles made up a complete hexagon. So if I were to mark all these angles as 60 degrees, so what do you observe now? Look at the point O, the center of the circle. If I now go and erase this complete figure, the complete circle and all those triangles, and I leave only the angles at the center, if I do that over here, what do you observe? Do you see that there are 6 parts of 60 degrees which are making up the whole angle at the center, and 6 times 60 is going to be 360. So this seemed a very interesting story. There are a couple of more reasons, or maybe it's just an hypothesis. There are a couple of reasons why people think that angle around a point is 360 degrees. But I found this really convincing because I am able to construct it and I am able to verify it as well. So since Babylonians had a number base of 60, they found that angle around a point is 360. So if their base of counting was, say, for example 80, then what would have happened? There would be 6 angles of 80 degrees around a point, and you will notice that 80 times 6 is going to be 480 degrees. So instead of having an angle around a point as 360 degrees, the angle around a point would have been 480 degrees. So later on, as time passed, mathematicians found that this effect of 60 times 6 is a completely random concept. Since the counting base was 60 in case of Babylonians, the angle around a point turns out to be 360. Had it been 80, it would have turned out to be 480 degrees. So to rectify that particular problem, or to rectify that particular randomness, they came up with a new unit for angles, which was named as radians. So I hope that you found this particular idea interesting. This story is really interesting. It shows how intuitive Babylonians were, and they did experiment with equilateral triangles, and they were able to frame the concept that angle around a point is 360 degrees, which actually forms the base for all the geometry here on. So if the angle around a point is 360 degree, then angle around a line is 180 degree. Then you can prove that sum of all angles in a triangle is 180 degree, and so on. So this is where the angles in geometry were really born, and this property is immensely useful. This forms the whole basis for geometry and angles. I hope you found this particular story interesting. So I do hope that after watching this video, geometry makes more sense to you. Do like, share and subscribe my video channel and stay connected for more updates. Let's learn mathematics. Let's enjoy mathematics. Goodbye.